Hi dear students, welcome to our channel Maths with Panindra. In this video, we are going to discuss about Gauss-Jordan method to solve the given system of equations. See, let us have a concept. First, we have to discuss about what is the procedure to calculate the solution of given system of equations by using Gauss-Jordan method. Given system of equations. So the system of equations a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. These are the system of equations, given system of equations, dear students. In the earlier classes, matrix inversion method as well Cramer's rule, both the methods I explained in the previous classes. Once you go through the matrices intermediate maths 1a playlist, it will be available in our channel. Otherwise, I will provide in the link in the description box. You can go through, dear students. So first, the given system of equations write in the form of ax is equal to d, where a is coefficient matrix. So a equal to, we are writing x, y, z coefficients, you have to write it. A equal to a1, b1, c1, a2, b2, c2. Next a3, b3, c3. This is a. Capital X equal to, this is the solution matrix. This equation contains the unknown values x, y, z. So capital X equal to small x, small y, small z. This is the solution matrix. This is coefficient matrix. Capital D equal to constant matrix. The constants are there here. D1, D2, D3. First, from the given system of equations in the question, first you write given system of equations and write what is A, what is X, what is D. To solve the given system of equations by using Gauss-Jordan method, you need to write augmented matrix, augmented matrix, augmented. What is meant by matrix, augmented matrix? It is denoted by capital AD. That means the combined matrices of coefficient and constant. The combined matrices of these two is called augmented matrix. See here, A1, B1, C1, D1, the last column, fourth column, filled with D. So A2, B2, C2, D2, A3, B3, C3, D3. But how to calculate the solution for the given system of equations by using Gauss-Jordan method? First, from the given system of equations, we wrote Ax equal to D form. And what is A, what is X, what is D, we wrote it. Next, augmented matrix, the combined matrices of A and D, we wrote it. This matrices is there now. Observe carefully, dear students. After writing of this augmented matrix, the first step is make in the first column A2 and A3. These two terms make zeros by using R1, by using row elementary operations. Make A2 and A3 elements are zeros by using R1, that means row 1, by elementary row operations. That is the first step. In the second step, make zeros B1 and B3, B1 and B3, zeros by using R2, by using elementary operations, row operations. After that, again make elements C1 and C2 make zeros by using R3. By using R3. After that, it will be converting into this form. 1, 0, 0, alpha. Next, 0, 1, 0, beta. After that, 0, 0, 1, gamma. This is called echelon form. After getting up this matrix, small x equal to alpha. This is the solution matrix, dear students. Small y equal to beta. Whatever the values we have here, after operating these steps, you will get the solution of given system of equations by using Gauss-Jordan method. I will give one example, dear students. One or two examples I will discuss here. So z is equal to gamma. This is the procedure to calculate solution of given system of equations by using Gauss-Jordan method. I will take one example to get the solution for the system of equations for this example. The example for this Gauss-Jordan method is, students, solve the following equations by Gauss-Jordan method. 2x minus y plus 3z equal to 9, x plus y plus z equal to 6, and x minus y plus z equal to 2. So according to the procedure, what we have to write is given system of equations. Given equations or given system of equations. So first write the equations. 2x minus y plus 3z is equal to 9. X plus y plus z equal to 6. X minus y plus z equal to 2. After that, what we have to write? The given system of equations, write in the form of Ax equal to D form. In this, A equal to 2 minus 1, 3, 1, 1, 1. Next, 1 minus 1, 1. A value we got it. Capital X equal to x+y+z and D equal to 962. So next what we have to write it? Augmented matrix. So the augmented matrix AD equal to 2 minus 1, 3, 9, 1, 1, 1, 6, 1 minus 1, 1, 2. So what is the first step after writing augmented matrix? We need to make this element and this element I want to make zeros. So this element I want to make zeros by using R1. See here, R2 tends to, so R2 tends to. If you multiply this value with 2, so 2 into 1, 2 only will come to 2 minus 2. So that is the reason 2 times of R2 minus R1. Similarly, R3 tends to, even this number also multiplying by 2. So 2 into R3 minus R1. So these values, if you want, you can separately, you can calculate, dear students, these values. So R2, 2R2, how it will come is, here I will explain. 2R2, that means 2R2 value I am writing. in the examination are required to write this. So 2, 2, 2 and 12. R1. R1 means what? 2 minus 1, 3, 9. So here 2R2 minus R1. So indirectly what we are subtracting only now. So minus, plus, minus, minus. So 2 minus 2, 0. 2 minus 2 minus or minus 1, 2 plus 1, 3. 2 minus 3, minus 1, 12 minus 9, 3. So in place of R2, 2R2 minus R1 only now. So here you replace with this value. Similarly, R2 R3 minus R1 also calculate. 2 or 3. So multiplying by 2. So 2 minus 2, 2, 4. R1. R1 is as it is 2 minus 1, 3, 9. So we are subtracting, dear students. 2 or 3 minus R1. So whenever subtracting, sign change. 2 minus 2, 0. Minus 2 plus 1, minus 1. 2 minus 3, minus 1. 4 minus 9, minus 5. So in place of R2, this is R2 value. This is R3 value. So this will becomes, so AD, this you have to do in the right side, in the rougher place, dear students. So first step here completed. So R1 we are not changing anything. 2 minus 1, 3, 9. Next here R2. R2 value, this only write it here. 0, 3, minus 1, 3. Next R3 value. 0, minus 1, minus 1, minus 5. Did you understand this? We made these two values zeros only now. In the next step, what we are going to do is these values making zeros by using R2. Observe carefully, dear students. Learn thoroughly. After doing one or two problems, you will be perfect in the Gauss-Jordan method, dear students. See here, we are not changing R2, R1 and R2. So according to this, here 3 is there, here I want to make this value is 3. So minus 1 is there. If you multiply with 3, minus 3, if you do that minus 3 means it won't come 0. So minus 3 plus 3. So that time R1 tends to 3R1 plus R2. Then it will become 0. Even here also. R3 tends to 3 times of R3 plus R2. So just I will write it here, dear students. See here what we are going to apply row operations. R1 tends to this one multiplying by 3 times of R1. So 3 times of R1 means minus 3 will come here. I am talking about this value. Plus 3. Plus 3 means here plus R2. Then only this value will become 0. Our aim should be this value making zeros. Like solving equations, eliminating x, eliminating y, how we are doing? This is the way we are doing here. Next, R3 value I want to make 0. So R3 tends to, this value also multiplying by 3. 3 times of R3 plus R2. So this value separately we will calculate. So 3R1, that is equal to each and every term of R1 value multiplying by 3. So 3 2s are 6. Minus 3. 3 3s are 9. 3 9s are 27. Next, R2. R2 value as it is you write it 0 plus 3 minus 1 plus 3. So here the thing is R3R1 plus R2 no. So 3R1 plus R2. If you add these values R2 plus here the thing is plus, here the thing is minus. Not here, dear students, here. Even here also. But here plus 6 plus 0, 6 minus 3 plus 3, 0, 9 minus 1, 8, 27 plus 3, 30. That is 3R1 plus R2. Next, 3R3 plus R2. 3R3. So R3 multiplying by 3. 0, minus 3, minus 3, minus 15. Next, plus R2 value. R2 you write it as it is 0, 3, minus 1, 3. Now we are adding these values, dear students. 3R3 plus R2 is equal to 0, 0, minus 3 minus 1, minus 4, minus 15 plus 3, minus 12. So therefore, after applying these row transformations, so this AD will becomes, so first row, this is the first row, 3R1 plus R2 will becomes 6, 0, 8, 30. R2 we are not changing anything. 0, 3, minus 1, 3. Next R3 also we are going to change it. This is R3. 0, 0, minus 4, minus 12. I hope you understand, dear students. These values we made 0. These values also we made 0. Before that, here one more important thing. Here 6, 8, 30. The first row divisible by 2. So to make simplest form, last row also divisible by minus 4. That we can make it. R1 tends to, this is not the method. Just wherever convenience is there, we can do like this. R1 divided by 2. R3 tends to R3 divided by minus 4. So this matrix will become, this augmented matrix will becomes, dividing by 2 means it will become 0, 3, 0, 4, 15, 0, 3, minus 1, 3. Next 0, 0, dividing by minus 4. 4 3 is all. In the next step, what we have to do? We want to make these values 0 by using R3. In the previous steps, first step, these two values made 0. In the second step, these values made 0. In the third step, we are making these values 0 by using R3. See how it will comes. Observe it, students. These values I want to make 0. So R1 tends to R1 that value is 4. Here 1 is there now. By using this one means minus 4 times of R3. 4 into 1. 4 minus 4. Then only it will become 0 now. So how to, this will become 0. R2 tends to, here plus 1, here minus 1. If you add these two, plus 1 minus 1, 0 will come. So R2 plus R3. So these values we will make it. So R1 as it is we are writing 3, 0, 4, 15. Next 4R3. 4R3. So this is the R3 value multiplying by 4. 0, 0, 4, 4 is the 12. We are subtracting, dear students, minus. So R1 minus 4R3. 3 minus 0, 0 minus 0, 4 minus 4, 0, 15 minus 12, 3. We got it now? Next what we are doing step? Here R1. Next R2 plus R3. R2. What is R2 value? This is R2 value. 0, 3, minus 1, 3. R3 value. R3 value 0, 0, 1, 3. 0, 0, 1, 3. We are adding these values, dear students. Plus is there. So R2 plus R3. 0, 3, 0, 3 plus 3, 6. So these two you write in the next augmented matrix. I will rub this, dear students. I will write it. Yeah. Here in this we are going to apply these values. So augmented matrix AD is approximately equal to. So we are not changing R3 value, no, as it is 0, 0, 1, 3. As it is we are writing. So R3, R1, R2 values. This is R1 value, this is R2 value. 3003. 3003. Next, R2 tends to R2 plus R3. R2 plus R3 value is this one, 0306. 0306. Observe, dear students, the first row all are multiples of 3, second row all are multiples of 3. So R1 tends to R1 by 3, we can write it. Similarly, R2 tends to R2 by 3 also. So after applying these row operations, it will becomes 1001. Next 0, 1, 0, 2, 0, 0, 1, 3. This you have to compare with echelon form. That means 1, 0, 0 alpha, 0, 1, 0 beta, 0, 0, 1 gamma. So by comparing, we know that x is equal to alpha, which is equal to 1. Y is equal to beta, that is equal to 2. Comparing fourth column. So Z is equal to gamma, which is equal to 3. Therefore, the solution of given system of equations, therefore, the solution of given system of equations is capital X equal to x, y, z, that is equal to 1, 2, 3, or we can write like this also, that is we can write it as x is equal to 1, y is equal to 2 and z is equal to 3. If you want whether it is correct answer or right answer, 1, 2, 3 substitute in any equations. In this equation I am substituting 1 minus 2 plus 3. 3 plus 1, 4, 4 minus 2 is 2. Satisfying. Come to second equation. 1 plus 2 plus 3. So 1 plus 2, 3, 3 plus 3, 6. 6 is there. RHS. So every equation is satisfying. So our answer is right answer. I hope you understand the method of Gauss-Jordan to get the solution of given system of equations. Still any doubts are there, please write to my comment box. I will help you. In the coming days, more examples I will give in this Gauss-Jordan method as well, inverse matrix inversion method and Cramer's rule. I hope that is already done, the videos based on that. In the coming days, I will make different questions based on this Gauss-Jordan method. I will give in the coming days. Thank you for your support.